So here we go with review question number 1. We have a velocity function, and we know that at time 0 the position is 7. So first question, when is the particle moving to the right? Give a reason. Basically you take your velocity, set it equal to 0. You can use the calculator, graph the velocity, and see when it crosses the x-axis and do your number line that way. Or tricky trinomial factoring, there we have it. Our two critical points are at 2/3 and at 2. So we do our number line, we see between 0 and 2/3 we're moving to the right, we have a positive velocity. And then we have a negative velocity moving to the left and then moving to the right from 2 to 4. So our intervals where the particle is moving to the right, 0 inclusive to 2/3, and then 2 to 4 inclusive. 0 and 4 are included because on the original interval given, they were included and they are not critical points. Part B, when is the particle moving to the left? Again, we just have to look at the work we just did, and the particle is moving to the left from 2/3 to 2 because the velocity is negative. You have to give your reason. When it says give a reason, state in words, okay? Number line is not enough, must say it in words. Part C, average acceleration. Average acceleration is the average rate of change of the velocity. So you just do the velocity at 4 minus the velocity at 0 over 4 minus 0. Be careful with your arithmetic. Remember, for the AP, you can stop right there. You don't have to go all the way down to 4. You can leave it at 20 minus 4 over 4. Okay. Part D, find the acceleration of the particle time t equals 1. Acceleration is the derivative of the velocity. So the derivative of 3t squared minus 8t plus 4 is just 6t minus 8. Then sub in 1. And again, you can leave it at 6 minus 8. You do not have to go all the way to get to -2. We'd rather you leave it at 6 minus 8 so you don't make a careless mistake. Part E is the speed of the particle increasing or decreasing at t equals 1, and give a reason. Speed is when we look at it, velocity and acceleration together. So we need the velocity at 1 and the acceleration at 1. When velocity and acceleration have the same sign, the object is speeding up or the speed is increasing. When velocity and acceleration have opposite signs, the object is slowing down or the speed is decreasing. Since these are both the same sign, they're both negative, and we don't care if they're both positive or negative, we just want them to both be the same side, the speed is increasing or it's speeding up. Part F, position function for the particle. Okay, position is the integral of the velocity. We do it as an indefinite integral, so we include the plus c, but let's remember we also know that the position at 0, at time 0, is 7, so we can solve for c. So our end result is this position function. Don't forget the plus c. So really what you're doing there on part F, you're solving a differential equation with an initial value. Part G, use the position function to find the values of x of 1 and x of 4. Just subbing in, we get 8 and 23. And then part H, the total distance traveled by the particle on the time interval. Total distance traveled is the integral of the absolute value of the velocity, or if we're doing it this way, we find our position at the endpoints and we find our position at any time where the particle changes direction on that interval. And we knew from an earlier part that at time t equals 2, the particle turned around. So our position at 1 is 8, our position at 2 is 7, and our position at 4 is 23. We then find the differences in those positions. Going from 8 to 7, we moved 1. Going from 7 to 23, we moved 16. We don't care about the direction. We're looking for total distance traveled. Add up the 1 and the 16, and we get 17.